Good day, grade 10 learners! This is your school on the air in Mathematics 10. I am Teacher Anna, your grade 10 radio teacher of Benigna S. Aquino National High School. Today, we will learn about division of polynomials. Are you ready? But before we start, kindly prepare your self-learning module, your pen, and paper to write your solutions and answers as we progress with our discussion. Also, look for a place in your home where you feel comfortable and safe. And most importantly, prepare yourself to watch and listen carefully. At the end of this lesson, you are expected to perform division of polynomials using long division and synthetic division, proves the remainder theorem and the factor theorem. Let's begin with the division of polynomials. If you are using the Mathematics Learners module for grade 10, kindly open it on page 57. If you are using the Compendium of Notes, turn it on page 28. But if you have a copy of the Alternative Delivery Mode Self-Learning module in Mathematics 10, prepare the module about the division of polynomials. In this lesson, we need to be familiarized with the following terms. What is polynomial? A polynomial is an algebraic expression where the exponent of the variable is a positive integer or zero. There are no variables in the denominator or under the radical sign. Standard form of polynomials. It means writing the terms in decreasing powers of the variable. Example: P of x is equal to 3x raised to 4 plus 5x raised to 3 minus 2x raised to 2 minus 3x plus 1. Notice that the exponents are in decreasing order. Another example is P of x is equal to x raised to 3 minus 4x plus 5. In here, the second degree is missing, but we can also write it as P of x is equal to x raised to 3 plus 0x raised to 2 minus 4x plus 5. We write 0 as the numerical coefficient of the missing degree. Another note that you need to remember in dividing polynomials is that you have to consider that p of x and d of x are polynomials, where the value of d of x is not equal to 0. Because if that is the case, it will give us undefined. Also, the final answer must be written in the form q of x plus r of x over d of x, wherein q of x is the quotient, where r of x is the remainder, and d of x is the divisor. There are two methods in dividing polynomials. That is using the long division and the synthetic division. Long division. When we say long division, it is a lengthy procedure in dividing polynomials where all operations are applied. Here are the steps in solving using long division. Number 1. The polynomials should be in standard form. If there is a missing term, place 0 to complete the term. Example: divide 2x raised to 2 plus 5x minus 23 by x plus 5. Let us check if the given polynomials are in standard form. The first exponent is 2. Then the second one is 1. Then we don't have any exponent, meaning to say it is in standard form. Also, there are no missing term in the first polynomial. Next is x plus 5. This one is in standard form. The exponent is 1, then we don't have any exponent written on the second number. So we have 2x raised to 2 plus 5x minus 23 divided to x plus 5. The second step is divide the first term of the polynomial to the first term of the divisor. So the first term of the polynomial is 2x squared, while the first term of the divisor is x. Dividing them, we have 2x squared divided to x. The answer would be 2x. Third step, distribute the quotient to the divisor. The quotient is 2x. We need to multiply it to the divisor, x plus 5. 2x multiplied to x will give us 2x raised to 2. Then 2x multiplied to 5 will give us positive 10x. Step number 4. Subtract the product of the terms to the given polynomials, then bring down the next term. Subtracting the product of the terms to the given polynomials will lead us in changing the sign of the product of the terms. From positive 2x squared, it will become negative 2x squared. Then from positive 10x, it will become negative 10x. Positive 5x minus 10x will give us negative 5x. Then 2x squared minus 2x squared is equal to 0, or simply cancelled it out. Then we need to bring down the next term, which is negative 23. So we have negative 5x minus 23. Step number 5. Repeat the step until there is no term to bring down. We stop at negative 5x minus 23. Negative 5x divided to x will lead us to negative 5. The negative 5 multiplied to x plus 5 will give us negative 5x minus 25. Then we subtract the terms. From negative 5x, it will become positive 5x. Then from negative 25, it will become positive 25. Negative 23 plus 25 is equal to 2. Then negative 5x plus 5x is equal to 0, or simply cancelled it out. Then there are no terms to bring down, therefore we consider 2 as the remainder. Step number 6. Write the final answer. The remainder should be written in fraction form, following this format: q of x plus r of x over d of x. Q is the quotient, which is 2x minus 5. Then r is the remainder, which is 2. Then d of x is the divisor, which is x plus 5. So when we divide 2x squared plus 5x minus 23 by x plus 5, the answer is 2x minus 5 plus 2 over x plus 5. And that's it. We only have 6 steps in solving using long division. Now, ready your pen and paper and try to solve for this one using long division. Divide 3x raised to 3 plus 4x raised to 2 plus 8 by x plus 2. Again, divide 3x raised to 3 plus 4x raised to 2 plus 8 by x plus 2. I will give you 1 minute to solve for this one. Three, two, 1. Time is up. So when we divide 3x raised to 3 plus 4x squared plus 8 by x plus 2, it will give us 3x raised to 2 minus 2x plus 4. In this given, the remainder is equal to 0. So therefore, we don't need to write r of x over d of x. Again, the final answer is 3x raised to 2 minus 2x plus 4. Now, let's talk about the other method in dividing polynomials. We have the synthetic division. A synthetic division is the shortest way of dividing polynomials using addition and subtraction as an operation. Here are the steps in solving using synthetic division. Number 1, make sure that the given polynomials are written in standard form. Write only the numerical coefficient, then equate to x the numerical of the divisor. Example, divide 2x raised to 2 plus 5x minus 23 by x plus 5. Looking closely at the given, we can say that the given polynomials are written in standard form because the exponents are in decreasing order. Then next, we need to write the numerical coefficient. Let's take a look at the divisor. We have x plus 5. So we need to equate it to x. To do that, we need to equate x plus 5 to 0. So we have x plus 5 is equal to 0. Transposing positive 5, it will become negative 5. Therefore, the value of x is equal to negative 5. So we write negative 5. Negative 5 is the numerical of the divisor. Then we need to write the numerical coefficient of the polynomial 2x raised to 2 plus 5x minus 23. The numerical coefficients are 2, 5, and negative 23. Step number 2, bring down the leading coefficient. The leading coefficient is 2. So we bring down 2. Step number 3, multiply the number in the box with the number you brought down, then write the answer in the next column. So the number that we brought down is 2, and the number that is written on the box is negative 5. So 2 multiplied to negative 5 is equal to negative 10. So we write negative 10. Step number 4, add the two numbers together, then write your answer below the two numbers. So we have 5 and negative 10. If we add them, the answer would be negative 5. Step number 5. Repeat the steps until there is no numerical coefficient to bring down. So we stop at -5. So the next step would be multiplying -5 to the number in the box. So we have -5 multiplied to -5 will give us positive 25. Then adding the two terms, we have -23 plus 25. The answer is 2. Then we don't have any numerical coefficient to bring down. Therefore, we considered 2 as the remainder. Step number 6. Write the final answer. The variables or x start up 1 power less than the dividend and go down 1 with each term. The remainder should be written in fraction form. So we have 2, -5, and 2. So the dividend is 2x squared plus 5x minus 23. The degree of the given polynomial is 2. So in step number 6, the rule is to subtract 1 to the degree. So the degree is 2, so we subtract 1. So we have 2 minus 1 is equal to 1. So the exponent of the variable in the quotient would start at 1. So we have 2x. Then we have minus 5. Then we write the remainder, which is 2. Then the divisor, which is x plus 5. Therefore, if we divide 2x squared plus 5x minus 23 by x plus 5, the answer would be 2x minus 5 plus 2 over x plus 5. But what if the numerical coefficient of the variable x in the divisor is greater than 1? For example, 2x minus 1. So if that is the case, you need to solve for the value of x first. So to do that, we need to equate the given divisor to 0. So we have 2x minus 1 equal to 0. Then transposing -1, we have 2x equals to positive 1. Then in order for us to get the value of x, we need to divide 2 both sides to eliminate 2. So we have 2x over 2, which is equal to 1/2. 2x over 2 is equal to 1x, or simply write x. Then we have 1/2. So therefore, the value of x is equal to 1/2. Let's have an example. Divide p of x, which is equal to 4x raised to 3 plus 6x raised to 2 minus 2x plus 4 by 2x minus 1. Then find the remainder of the given polynomial. Following the steps in dividing polynomial using synthetic division, the number written on the box would be 1 over 2 because the value of x in the divisor is 1/2. Then we need to write the numerical coefficient of the polynomials given on the dividend. We have 4, 6, -2, and 4. We write them as it is because the given polynomial is already in standard form. Then we need to bring down the leading coefficient, which is 4. Then we need to multiply 4 to the number written on the box, which is 1 over 2. So 4 multiplied to 1/2, it is equal to 2. Then 6 plus 2, we have 8. 8 multiplied to 1/2, we have 4. Then -2 plus 4, we have 2. Then 2 multiplied to 1/2, the answer would be 1. And 4 plus 1, we have 5. There are no terms to bring down, therefore we considered 5 as the remainder. But wait, it is not yet the final answer. Remember that the numerical coefficient of the variable x in the divisor is greater than 1. So the number written on the box is 1/2. So the next step in here would be dividing 4, 8, and 2 to 2. From 1/2, we need to divide 4, 8, and 2 to 2, except the remainder. So we have 4 divided to 2. The answer would be 2. Then 8 divided to 2. The answer would be 4. Then 2 divided to 2. The answer would be 1. So from 4, 8, 2, it will become 2, 4, and 1. So again, we have 2, 4, 1 plus the remainder, which is 5. So the answer now would be 2x raised to 2 plus 4x plus 1 plus 5 over 2x minus 1. So that's it. We also have 6 steps in dividing polynomials using synthetic division. Now, get your pen and paper and try to solve this one using synthetic division. Divide 2x plus x raised to 3 plus 7x raised to 2 minus 40 by x minus 2. Again, divide 2x plus x raised to 3 plus 7x raised to 2 minus 40 by x minus 2. I will give you 30 seconds to solve for this one. Your time starts now. Okay, when we divide 2x plus x raised to 3 plus 7x raised to 2 minus 40 by x minus 2, the answer is x raised to 2 plus 9x plus 20. Again, the answer is x raised to 2 plus 9x plus 20. Did you get it right? Let us now talk about the remainder theorem. In the previous example, we always see the remainder in each polynomials that we divide. But if you are just looking for remainder, we can use the remainder theorem. We don't need to divide the given polynomials by using synthetic division and long division. So what is remainder theorem? Remainder theorem, it states that if p of x is divided by x minus r, the remainder r is constant and is equal to p of r. In short, the value of x will be substituted in the variables in the given polynomial. For example, find the remainder when p of x is equal to 4x raised to 3 plus 6x raised to 2 minus 2x plus 4 is divided by 2x minus 1. The value of x is equal to 1/2 in the divisor. So substituting the value of x in the given variable x, we have 4 multiplied to 1 over 2 raised to 3 plus 6 multiplied to the value of x, which is 1/2 raised to 2 minus 2 multiplied to 1/2 plus 4. 1/2 raised to 3 is equal to 1 over 8, and 1/2 raised to 2 is equal to 1 over 4. Then negative 2 multiplied to 1/2 is equal to negative 1. 4 multiplied to 1 over 8 will give us 4 over 8. 4 over 8 is equal to 1 half. And 6 multiplied to 1/4 will give us 6 over 4. Or the simplified form is 3 over 2. Then negative 1 plus 4 is equal to positive 3. Then 1 over 2 plus 3 over 2 is equal to 4 over 2. So 4 over 2 plus 3 is equal to 2 plus 3. 2 plus 3 is equal to 5. The remainder when we divide 4x raised to 3 plus 6x raised to 2 minus 2x plus 4 by 2x minus 1 is 5. In here, we use the remainder theorem. But notice that in the second example in the synthetic division, it is similar to the remainder that we get. So we also have 5. Now, get your pen and paper and try to solve for the remainder of 5x raised to 2 minus 2x plus 1 when it is divided by x plus 3. Again, find the remainder when 5x raised to 2 minus 2x plus 1 is divided by x plus 3 using the remainder theorem. I will give you 30 seconds to solve for this one. Your time starts now. Okay, time is up. The remainder when we divide 5x raised to 2 minus 2x plus 1 by x plus 3 is 52. Again, the remainder is 52. But what if the remainder is 0? When the remainder is 0, it refers to factor theorem. So what is factor theorem? Factor theorem, it states that the polynomial p of x has x minus r as factor if and only if p of r is equal to 0. In short, the divisor is considered factor of the given polynomial if the remainder is 0. For example, we need to show that x minus 2 is a factor of 2x raised to 3 plus 4x raised to 2 minus 10x minus 12. So to solve that, we need to use the remainder theorem, substituting the value of x in the given polynomial. So we have 2 as the value of x in the divisor. So we have 2 multiplied to 2 raised to 3 plus 4 multiplied to 2 raised to 2 minus 10. The value of x is 2. 10 times 2 minus 12. 2 raised to 3 is equal to 8. And 2 raised to 2 is equal to 4. So 10 times 2 is 20. So 2 times 8 is equal to 16. 4 times 4 is 16. Then negative 20 minus 12, the answer would be negative 32. Then 16 plus 16, the answer is 32. Then bring down negative 32. So 32 minus 32 is equal to 0. So in here, we prove that x minus 2 is a factor of 2x raised to 3 plus 4x raised to 2 minus 10x minus 12. Because the remainder is equal to 0. Now, Ready your pen and paper and try to identify if x minus 1 is a factor of x raised to 2 plus 2x plus 5. Again, identify if x minus 1 is a factor of x raised to 2 plus 2x plus 5. Your 30 seconds starts now. Okay, identifying if x minus 1 is a factor of x raised to 2 plus 2x plus 5, the answer is no. X minus 1 is not a factor of x raised to 2 plus 2x plus 5 because the remainder is equal to 8. Remember that in order for a divisor to become a factor of a given polynomial, the remainder must be equal to 0. And that ends our lesson for today. I hope you learned something. Again, this is Teacher Anna of Benigna S. Aquino National High School. See you in our next episode on air. Keep safe, everyone.